Assalamu alaikum dear students. Our today's topic is measurement of price elastic demand, geometric method or the point method. You see, Marshall devised a geometric method for measuring elasticity at a point on the demand curve. Let RS be the straight line demand curve in this figure 1. If the price falls from PB to MD, then the quantity demanded increases from OB to OD. See, elasticity at point P on the RS demand curve according to the formula I can show you here. You see, that means price elastic demand is equal to change in Q by change in P into P by Q. If you see this figure, in this figure, change in Q, that's equal to BD. Also, that's equal to QM, and that's the change in Q. And change in P, that's equal to PQ. Change in P is equal to PQ, and the initial price and quantity is P is equal to PB and Q is equal to OB. You see, now when we substitute these values in the elastic formula, you know, the price elastic demand is called change in Q by change in P into P by Q. So here change in Q, that's equal to BD or QM. We will write down here QM. The change in Q is called BD or QM. We will write down here, when we substitute these values in the formula, we will write down like this: QM by change in P is equal to PQ. QM by PQ into price is equal to PB and Q is equal to OB. Moreover, we can say that QM by PB, that's also called BS by PB. See how. QM, I will show you in the diagram here. You see, QM by PB, that's also equal to BS by QM by PQ is equal to BS by BP or PB, right? You see, it's because the angle PQM is equal to angle PBS, being right angles, and PQM and PBS are similar triangles. You see, now here we can also say that therefore BS by, when we will write down this instead of this, that means BS in the formula BS by PB into PB by OB. Then we cancel these two. When we multiply this, we will find out that will be equal to BS by OB. Now you see, since triangle PBS and ROS, you see here PBS and ROS, these triangles are similar. PBS and ROS, these triangles, since these triangles are similar, the elastic demand at point P, that will be equal to BS by OB, and that will also be equal to OA by AR, or if we can say that will be equal to PS by PR. That means lower segment by upper segment. Here I can show you here that since triangle PBS and ROS are similar, elastic demand at point P is equal to BS by OB, that's equal to OA by AR, and that's equal to PS by PR. That will be equal to lower segment by upper segment. You see, now with the help of the point method, or geometric method, it's easy to point out the elasticity at any point along a demand curve. Suppose that this straight line demand curve DC in this figure 2 is 6 centimeters. The 5 points L, M, N, P, Q are taken on this demand curve. See, the elastic demand at each point can be known with the help of the above method. Let N be in the middle of the demand curve. So the elastic demand at point N, that will be equal to Cn, lower segment, divided by Nd, that's called upper segment. So that will be equal to 3 divided by 3, that will be equal to 1. So the elastic demand at point N is equal to unity. Elastic demand at point N is equal to unity. Now, elastic demand at point M, you see, suppose this is 1, let it be here, second, third, fourth, fifth, sixth. Now, elastic demand at point M, see, that will be equal to Cm by Md. That means 5 divided by 1. Cm by Md, that will be equal to 5 divided by 1. That means elastic demand here is called 5, that's greater than unity. Elastic demand at point M is greater than unity. Here in this diagram, at point M is greater than unity. Now, elastic demand at point L, that's equal to Cl divided by Ld. That means that will be equal to 6 divided by 0. That will be, and 6 divided by 0 is equal to infinity. So the elastic demand at point L is infinity. You see, elastic demand at point P, that means Cp divided by Pd, that is equal to 1 by 5. It is less than 1, that means it's less than unity. Elastic demand at point P is less than unity, and elastic demand at point Q is equal to Cq divided by Qd. Cq divided by Qd, that will be equal to 0 divided by 6, that's equal to 0. So elastic demand at point Q is 0. So here I have shown here. Now we arrive at the conclusion. Here we arrive at the conclusion that at the midpoint on the demand curve, the elastic demand is unity. Moving up the demand curve from the midpoint, the elasticity became greater. When the demand curve touches y-axis, the elasticity is infinity. Any point below the midpoint towards y-axis, towards x-axis, will show the elastic demand, and elastic demand becomes 0 when the demand curve touches the x-axis.